Why we think we have district scale potential on this property, and it definitely has implications for other projects within the Golden Triangle as well. So I'll just go through our quick mandatory disclaimer here. There will be forward-looking statements within this talk, so do your own due diligence with investing. So where is the Eskay mining property? It's in the heart of the Golden Triangle. You see it's outlined right here in this gold color. And you can see that we're surrounded by lots of other world-class potential projects. For instance, the KSM Iron Cap porphyries of Seabridge, the Treaty Creek project of Tudor, notably the Eskay Creek mine that Skeena Resources is exploring again right now. This was historically the highest grade gold mine on the planet Earth. We have Garibaldi's E&L project over here, and then a host of other properties near our project. And what we have on Eskay Mining Project is predominantly VMS, or volcanogenic massive sulfide deposits. This is really what we're looking for, and that's also what Eskay Creek mine was a VMS deposit. So why do we want to look for these VMS deposits? Well, as I had just mentioned, Eskay Creek was the highest gold grade gold mine in the world when it was operating. And we see here is a graph that has deposit tonnage in millions of metric tons on the x-axis, and then the y-axis has gold grade in grams per ton. And you can see here that Eskay Creek is standing out far above the rest of these VMS deposits. But these are all gold-rich VMS deposits in this quadrant of the graph right here, and you can see that these are producing about 100 tons of gold, even though in particularly the case of Eskay Creek, it's a relatively modest tonnage. So we're talking about medium tonnage, very high grade gold deposits. And in some cases, they can also be base metal, lead, zinc, and copper deposits as well. However, Eskay Creek is predominantly a gold and silver deposit. So it's important to understand how VMS deposits form in order to truly comprehend our exploration strategy, because VMS deposits do not occur in isolation. They always occur in clusters, and this is because of the way that they form. So VMS deposits form in a back arc rift setting in a submarine environment. So we're in a tectonically extending environment. And we have the seafloor right here, and then these extensional normal faults within the rift graben itself. And then seawater will penetrate along these extensional faults, because faults are fractured up and serve as very good conduits for fluid flow. And then this magmatic intrusion of gabbro along the axis of the back arc rift supplies a heat source that drives a hydrothermal circulation system where this cold seawater is penetrating into the submarine or the subseafloor environment, gets heated up, and as it's interacting with this rock package, it's leaching out the metals such as gold, copper, lead, zinc, silver, and then it ascends up over the Pluton, where there's the most extension and the highest temperatures. These hot fluids rise up to the seafloor position, and it's in this area right here that we call the feeder zone that we can really start to see the evidence of volcanogenic massive sulfide activity. You'll have an alteration halo within this area, as well as in about the top 2 to 100 meters below the seafloor, start to get stockwork or feeder style sulfides precipitating out of solution, and then right on the seafloor actually start to form what we call massive sulfide mounds. This is what a lot of people call the exhalative horizon. This is the paleo seafloor. So that was looking at the cross section of these deposits, but as I said, they're forming in these back arc rift basins. We have several modern examples of these hydrothermal systems today. They're black smokers and white smokers on the seafloor by Japan. The Lau Basin north of New Zealand, it's actually where that large volcanic explosion happened a couple weeks ago, is in the right type of environment for forming VMS deposits. But what you can see, even in these modern examples, these yellow circles are all hydrothermal fields right here, and they're occurring right along these synvolcanic fault structures, and a lot of times focused where you actually have cross structures crossing these faults. Same thing again happening on the Juan de Fuca Ridge. We could go back to the Abitibi 2.8 billion years ago, and we see the exact same sort of structural control where these ancient VMS deposits right here are located at the intersections of these transform faults that cut across these synvolcanic extensional structures. So that explains why VMS occur on these trends along the rift faults. We just see that happening today. It's very well understood phenomenon how these things actually form. So this is a really key thing to understand, is that it's not always the seafloor horizon that you want, but the environment that's right below the seafloor horizon, because something occurs called sub-seafloor replacement, where the breccia pile, if you imagine you're on the ocean floor in this kind of fault environment, there's a lot of volcanic domes, breccia pile, and debris everywhere. And these hydrothermal fluids will actually ascend up through this pile of debris, and debris is effectively acting as a filter. And it forces these hydrothermal fluids to take a more circuitous path through this and precipitate out more of their sulfides. Because if you imagine this hydrothermal vent just vented straight into the seawater and created a black smoker, you're really just blowing all of those sulfides away into the seawater, and you're not forming a deposit. It's really this sub-seafloor replacement that is building these large deposits. For instance, the Noranda type deposits in the Abitibi. And actually, Abitibi also shows that these VMS deposits can occur as stacked deposits. It's not just one horizon that we're looking for. These mounds can form, where you have your hydrothermal activity feeding these mounds, but then something happens, say renewed magmatism, where lava is actually clogging up the synvolcanic feeder structure, interrupts your hydrothermal flow, stops the formation of these deposits and buries them under lava flows. And then when volcanism subsides and there's another period of volcanic quiescence, that's when these hydrothermal systems become reestablished and form a new mineralized horizon at a higher level in the stratigraphy. And this is a really key concept to understand for what we've got going on our deposit. So this is just an example of the Noranda rift structure, again showing, going kind of down the cross section of this feature, that there are several VMS deposits, again, located along defined horizons, and there's several of these horizons within the Noranda camp that occur across this rift structure and along strike at multiple stratigraphic levels. And this is something that I don't really think was quite comprehended in the Golden Triangle until recently with the drilling we've been doing, as well as Skeena Resources drilling some of their lower mudstone and even lower mudstone. I don't really want to get into this too much, other than to say there are ways that we can quantify hydrothermal alteration. This is very key thing to understand for vectoring towards these feeder zones, because there is a mineral zonation associated with these VMS feeder systems. In particular, silicification is the sort of alteration we want to see when we know we're actually in this seafloor proximal synvolcanic feeder structure. You're going to get this silicification in a ore proximal zone. And we were able to use that type of alteration to vector towards our upper massive sulfide horizon at TV this season. So turning to our property specifically now, I want to show you our property-wide SkyTIM survey right here. This has been very handy for defining a lot of the geological features in bigger structures, as well as mudstone horizons, and in particular at TV, we've been able to use SkyTIM anomalies to target actual sulfide mineralization. And then sitting next to it over here, this is our BLEG survey map. This is a bulk leach extractable gold. This essentially is sampling the clay-sized fraction in stream sediments and looking for gold adsorbed onto the clay particles. But what it does is it's avoiding the nugget effect, where you're really precipitating or getting these heavy minerals out of suspension in the water. That really adds a nugget effect where you're not getting the most accurate idea of how much gold is within these drainage basins. BLEG avoids that by using the gold adsorbed onto the clay particles. And what we can see is that we've got a few areas in particular that have very, very high BLEG results right here. Anything over 10 parts per billion is considered good. We've got several that are in the 20s and 30s along this whole section, but right here, this is the big red Vermillion C10 trend right through here. These are coming in as high as about 156 parts per billion gold, which is well over an order of magnitude higher than even a good value is. It's quite high. And then we also have another very strong BLEG anomaly over here up at the Scarlet Ridge area, and I'll be discussing both of those prospects. So we've done a complete rethink of the stratigraphy in the area. There's a lot of variability within the Hazelton group locally. So we have been using Joanne Nilsson's stratigraphic nomenclature. It does seem to describe what we have going on our property the best. However, there are some more details that aren't captured in some of the more regional reports on the area. But we have right here, this would be our Sib-Lulu prospect right here. This is on the west limb of the Eskay anticline. So Eskay Creek Mine would be up here. So we're kind of coming along strike with Eskay Creek Mine right here. And what this is showing is that we have several different mineralized horizons just at Sib. In particular, the Lulu zone was intercepting mineralization within the Eskay rhyolite. This would be stratigraphically correlated with the lower mudstone at Skeena Resources. We also have trend of mineralization within the Bruce Glacier felsic unit, correlated with the even lower mudstone at Skeena. Several historic intercepts, including one up here that was at 61.9 grams per ton over a meter and a half. These would all be within the Spatsizi Formation. This is a dominantly sedimentary rock package. However, the mineralization is associated with some thin peperitic rhyolite intrusions within the Spatsizi Formation. And then going down even more, there were some intercepts within the Betty Creek Formation. And that's just at Sib. So we can go to other parts of the property, for instance, Cumberland, which is also on the west limb of the Eskay anticline, but about 10 kilometers south of Sib, actually has an intercept of the contact mudstone type mineralization. This is what the historic high-grade horizon at Eskay Creek was at the contact mudstone. So this is showing, that even 15 kilometers to the south of Eskay Creek, this hydrothermal system is still producing VMS deposits. We can go on to the east limb of the Eskay anticline. This is something that was just identified in 2020. A lot of the maps of the area don't show the Eskay anticline continuing this far to the south. However, we've been able to show that with field visits and drilling. And what we've intercepted at both TV and Jeff are VMS systems hosted within the Betty Creek Formation. This is a dominantly arc andesite formation. However, we've intercepted basalts and dacite, pepperite associated with both levels of mineralization at these deposits, and that's indicating that our interpretation is that we're having this very incipient early stage rifting of the volcanic arc, because clearly we're in a submarine environment based off the types of rocks that we have, a lot of mudstones and turbidites, but we're also getting the pepperite and this definitively VMS style mineralization, which I'll go into more detail about both of those. So I don't want to go into this in too much detail, but it's important to understand the stratigraphy and put it into a broader volcanotectonic picture. And what we're really seeing here is that the rocks that are hosting TV and Jeff are right into this Betty Creek formation here. However, we're getting the incipient rifting of this back arc, and the arc is rifting, and we're able to start to form some of these earlier VMS deposits like TV and Jeff. And then as the rift's opening up, you get the sedimentation of the Spatsizi formation. You also have the beginning of what would be true rift-related magmatism with the beginning of rhyolitic magmatism that you have within the Spatsizi formation, again associated with mineralization. And then, as I said, we'll get into this full-blown bimodal rift-related volcanism that starts out as rhyolitic and then becomes dominantly mafic or basaltic before volcanism terminates. And then we just go back to sedimentation of background sedimentation, and the Bowser Lake group represents all the post mineralization sedimentary rocks. However, it's also important to note that we do have folding and thrusting in this area, and that's what really accounts for the distribution of the mineralogy, is this combination of the stratigraphy plus understanding what the geological structures are. So Cumberland, I'll walk you through the stratigraphy starting at the contact mudstone. Cumberland is our intercept of the contact mudstone type mineralization, again on the east limb of the Eskay anticline. You can see right here is Cumberland, and then this whole trend of the anticline, there's Eskay Creek, Sib, Lulu. So we can show that not only does the contact mudstone horizon come out from under cover of this Coulter Creek thrust fault right here, but it also has gold and silver mineralization as well. For instance, this rhyolite right here is 5.6 grams per ton gold, and it was over limit at 100 grams per ton silver, and this was from the 2006 drill program. And that's a big part of what we're doing, is looking a lot of the old drill core on the property, because it is a valuable asset, and we're able to do some new interpretations looking at this. Going down below the contact mudstone, we have our Lulu zone. Again, this is a pepperitic rhyolite hosting predominantly silver sulfate salt mineralization associated with a fine electrum that we were able to identify using electron microscopy. Again, very high grade silver. This is just more or less a massive piece of miargyrite, which is a silver sulfate salt right there. So going down again in the stratigraphy, we're at the Spatsizi formation right here, and this is where we have our intercept of the pepperitic rhyolite, again associated with VMS mineralization right here. And this is stratigraphically equivalent to what Skeena is drilling at the Tamakai zone as well. That's just across our border and continues onto our property at Sib. So TV and Jeff is what we've really been focusing on for the last couple of years. Just looking at some of the historic drill core when I went up in 2020, that was all it took to convince me that we're dealing with a stacked VMS system at TV that had, people had drilled it, but they really weren't able to interpret what was going on at TV, particularly when we're talking about stuff within the Betty Creek formation where historically people really weren't looking for VMS type deposits. just to the east, that's the same stratigraphy that's hosting the Brucejack deposit and a lot of the porphyries over there. However, we can show that you go to the west on our property, and at that same period in time, we're getting a VMS deposits forming. And most notably, I can't emphasize this enough, TV, this mineralization outcrops on the surface. At TV, you could dig up the gold with a shovel out there if you wanted to. And then we did a part of our property-wide SkyTem survey focused even closer on TV and Jeff, and we're able to identify all of these conductivity anomalies that are associated and surrounding our known mineralization at both TV and Jeff. And they were also able to show that these trends of anomalies follow the stratigraphy, and particularly this one up here, that's a large band of carbonaceous mudstone. But what it does is allows us to really start to identify where these mineralized horizons are along strike. And then we're going to focus more on TV now. So looking at the TV Jeff system, this is one from our most recent press release, but what I like to do is show these systems. We're kind of looking down dip on the system, and the reason I do this is because this shows the true thickness of everything that's going on at TV and Jeff, where we're actually able to show, based on some historic drill holes from the early 90s, that we're able to correlate the stratigraphy from this lowermost part at Jeff all the way over here to near TV, where we have at Jeff our lower stockwork zone right here. This is, what this sort of stuff right here is. It's dominantly a basalt, andesite and dacite breccia infilled with a lot of stockwork sulfide. We have not intercepted any massive sulfide at Jeff yet. However, you get into this package of about 100 meters of unaltered mudstone, and then additional stockwork zone right up here at Jeff. And this is predominantly hosted within a dacite breccia. And then going all the way over here to TV, we're also seeing those same sorts of rock types within this lower massive sulfide zone at TV. And we do have some evidence with one of our drill holes, TV 2169, that we also have stockwork mineralization potential here, which is certainly plausible considering there are these two additional stockwork horizons lower down in the stratigraphy at Jeff. It's possible that there's prospectivity for additional stockwork below TV here, but we do have our lower massive sulfide horizon, a thin zone of unaltered sedimentary rocks, and then our second stockwork zone going up to our newly discovered massive sulfide horizon right there. And this stockwork zone here is what a lot of our most recent press releases have been reporting. So speaking of what we've identified there, these are maps and cross sections in gold equivalent right here, because we do have quite high silver values, getting up to 5 kilograms of silver per ton. And some of the rocks from right up here, this would be the upper most stockwork zone at TV coming right down here, and you can see it's dipping off to the east right here and is open down dip. This is critical. And then again, looking at our view of the system, looking towards the east down dip. So again, this is giving us our true thickness of the system. You can see that along strike, it's still open, and that we have a true thickness ranging between 50 and 90 meters over 250 to 300 meter strike length of this stuff that's coming in between 1 and 5 gram per ton gold equivalent on average. So our lower massive sulfide zone, as the name indicates, is massive sulfide. This sample up here is 5.46 grams per ton gold and 82 grams per ton silver. You're more than welcome to look at it when you come up here after the talk. And then just below the massive sulfide, you kind of get into a lot of this silicified mudstone. And again, that's what I had mentioned about using alteration as a vector. This silicification is what you find in this seafloor proximal feeder system going right up into this massive sulfide. So we're seeing the right sorts of alteration and the massive to semi-massive sulfide at this lower zone. And then going above that, up into here, this is what we call our stringer or stockwork mineralization right here. Again, predominantly hosted by intensely silicified mudstones right here. And this is where we're getting, this hole had our 92 meter intercept of pretty solid mineralization, as well as this one right here. There's a whole fan of holes that we're cutting along strike at TV and showing that we've got at least 100 plus meters of continuity of mineralization along strike at TV, as well as visible silver sulfur salt minerals like fibergite and pyrargyrite as our dominant silver minerals. So overlying the stockwork zone, even when we're out there logging it, we're like, this rock is intensely silicified. We've got to be close to the seafloor horizon. If we popped a pad up stratigraphic section from the stockwork drill holes, we should intercept massive sulfide, and that's what happened. We intercepted our massive sulfide horizon right here. There's actually quite a bit of clastic material where you have these sulfide clasts indicating that whatever chimney or mound this came from had been broken up and then re-cemented together by more sulfide minerals right here. And again, we also have visible pyrargyrite at the upper massive sulfide zone as well. And just starting to drill out some of these sky-time anomalies. So I should note that this anomaly right here, number 4, we tested that. That was the upper massive sulfide zone. There are a host of other anomalies lying along trend with that we'll be testing in 2022. But we also we're getting ready to drill out a lot of these before the snow stopped us. And this anomaly right here, number 7, is up stratigraphy from known mineralization at TV, and it's intercepted sulfide stockwork there as well. We do not have the assays back for this, so we don't know the grade, but at the very least what this shows is that there's still a VMS hydrothermal system that's extending 300 meters to the north of TV and up stratigraphy. So it's showing that this system actually has some real size to it. I mean, we can already show that the system goes to Jeff, but that it had a duration as well because of the presence of the VMS up stratigraphy. Oops, backwards. So going over to Jeff, so you'll see right away that Jeff is a lot different than TV. You still have these 2 stockwork zones. However, Jeff has very high grade mineralization surrounded by a broad halo of anomalous gold mineralization right here. We'll get stuff like this, which this is 79.2 grams per ton gold. We had several really good intercepts in 2020 and this year that are really characterized by this sort of, I'll call it Bruce Jack-like mineralization, where we're getting these high-grade intercepts, but the mineralogy is identical to what they're pulling out at Bruce Jack with electrum, pyrargyrite, pyrite, and then the rocks are intensely silicified and carbonate altered. They're very similar to what is going on at Bruce Jack and not coincidentally, these rocks are in the same stratigraphy that the Brucejack deposit is in. So, this really got me thinking maybe there's a connection between these deposits throughout the entire district as far as sourcing of hydrothermal fluids and the metal budget goes. That's something that we would like to investigate further. So this is what the high-grade mineralization at Jeff looks like. Again, dominantly sulfide-rich within mudstones or these really bleached peperitic basalt right here. This is a basalt that is white, but all these rocks are intensely hydrothermally altered. A lot of cases you'll see a well-developed fabric to these rocks because there is some deformation. Deformation and metamorphism does become more intense as you go southward on the property. And yeah, just some more examples of even recrystallization of the sulfide mineralization right here. So moving beyond TV and Jeff, so Jeff, TV right here, we'll continue our way down the east side of the Eskay incline over here to C10, and then we'll discuss Vermillion as well. So we're getting into the area where we have those really high Bleg anomalies right here. So we'll start off with this C10 map right here. This is just kind of a rough geologic map based off of some of our field observations from 2020 and 2021. And our drilling at C10. We identified actually that there's a thrust fault at C10 where the mineralization that's been intercepted historically is within the lower Hazelton group stratigraphy. Using our chemostratigraphic methods, we were able to show that C10 is at the same stratigraphic horizon as Jeff, most likely. But then going below this, so we have our lower Hazelton group rocks, like Betty Creek Formation rocks here, but below this, we get into a really faulted up zone, and then these drill holes intercepted the upper Hazelton group, notably the Willow Ridge basalt and the Eskay rhyolite and mudstones. So this is the contact mudstone horizon down here at C10. So now we're pushing, over 20 kilometers south of Eskay Creek. We're still getting the same upper Hazelton group stratigraphy on the east limb of the Eskay anticline, 20 kilometers to the south. And we can show that it's being faulted right here, which is critical for the exploration and geological interpretations. However, this is what's really interesting, is this sinistral fault structure that is offsetting these conductivity anomalies seen in the C10 image. And then we have our Bleg map right down here. These Bleg anomalies are associated with these sinistral structures. It seems there's almost an echelon kind of step over right here, another offset unit that's corresponding with this Bleg anomaly over here. So our interpretation is that this sinistral structure is a synvolcanic VMS feeder structure. I based that on the fact that Vermillion, where we had outcropping massive sulfide, this stuff right here is right on that structure. We've got several gabbro sills along this structure, which TV also has gabbro sills, but that indicates that you're in a rapidly extending fault near the rift axis, and you're actually getting a structure that's deep enough to tap into this gabbro that's really driving the heat source for these VMS deposits. So we have that evidence, and we also have Spearhead lying right along this structure, and I'll show you some photos of Spearhead as well, but again, more intensely altered sulfide stockwork at Spearhead. So we have numerous outcrops of massive sulfide, gabbro, all kinds of evidence indicating that, yeah, this is probably a synvolcanic feeder structure that's been reactivated as a sinistral strike slip fault during or after folding. So just quickly looking at what we've got at C10, just like at TV and Jeff, it's hosted by a peperitic dacite. However, at C10, the rocks are much more deformed, particularly in the upper plate to that thrust fault right here. But this is what the mineralization looks like, is just a very fine-grained, recrystallized foliation parallel pyrite within peperitic dacite. This right here is the contact between the basalt, Willow Ridge basalt, and the Eskay rhyolite right here, as well as some of the mud right here, mudstone that was associated with that contact. So again, confirming that we have that Eskay Creek horizon all the way down there to the south. Now Vermillion, as I said, we had found an outcrop of massive sulfide on the surface, and then upon drilling we identified quite a bit of pyrite stringers, sphalerite, some chalcopyrite. The rocks are much more chlorite altered than they are at TV and Jeff. And the mineral assemblage with the sulfide minerals as well as the chloride alteration, visible in core and on surface, suggests that Vermillion may be a more high temperature VMS system than what we have at TV and Jeff, which I didn't go into the details of it, but the alteration mineralogy at TV and Jeff suggests about 150 degrees Celsius temperature versus where you start to get chalcopyrite, you're pushing up towards 300 degrees plus Celsius temperature. But Spearhead, again, along this inferred feeder structure, is another outcrop of massive sulfide to semi-massive sulfide hosted by peperitic rhyolite right here. And you can just see, you know, in these photos, it's just loaded with pyrite, and historic surface samples graded up to 4.1 grams per ton gold. So there are several of these deposits along that structure, and that's one thing we'll be looking at in 2022, is really looking at that structure as well as defining this whole trend from Big Red north of Vermillion. This is a 6-kilometer trend of really hot Bleg anomalies, which Scarlet Ridge, that was identified using the Bleg survey right here. It came up as a really, really hot Bleg anomaly, and that is right here on the northeastern nose of our newly proposed eastern anticline right here. So this would be the McTagg anticlinorium. We still have to confirm it, but our stratigraphic investigations from the summer indicate there's probably a thrust fault right through here because, well, I'll show you what we've found out there. We found peperitic rhyolite. We're still waiting on the lithogeochemical analyses to confirm which rhyolite it is, but it's in the upper Hazelton group. So it's either going to correspond with the lower mudstone or the contact mudstone horizon, or both, because we have up on the ridge, on the eastern escarpment on this anticline, we have about 1.5 kilometers of Gaussian that is hosted by peperitic rhyolite riddled with pyrite stringers. And then down in the valley, there's a second parallel trend of peperitic rhyolite sills that's intruding into the mudstone. You can see right here, just very nice example of this kind of irregular contact. You've got your bedding right here, but then these bits of rhyolite fragmented and broken off as this magma is intruding into this wet, unconsolidated sediment. I mean, it's a textbook of what you want to find for VMS deposits. And then when you walk around to the back of this sill, you find stuff like this, where it's just riddled with sulfides cutting through all these rhyolites. So it's, you know, a pretty good bet that that Bleg anomaly that these are in is coming from all of these sulfides cutting through the rhyolite. This would be 2 of our mineralized horizons in the district. if not more. Because this has never been drilled right here. Further to the southwest, there were a few drill holes in the, I think, 1990 in the AP zone, and they intercepted up to about 3 grams per ton over 4 meters. And that's much further to the southwest, and not within a strong bug anomaly like this stuff right here is. Again, more pepperite just going all the way up the hill here. This is just one big VMS feeder system cutting up through all of this, and even getting into the semi-massive sulfide category. So again, I'd like to thank all of you for coming today, and I'd be happy to answer any of your questions, and please feel free to come up and look at some of our drill core. Thank you. Yep.
Have you guys done any kind of a preliminary metallurgical work on the property or not yet?
Not yet.
So is that a plan for this year or like?
I would really like to do that. What I will say, I've done, and some of my graduate students at Colorado School of Mines have done right phase surveys. So it's similar to the mineral liberation analysis. So we have a good idea of what our mineralogy is. Gold it seems to be hosted primarily by electrum. Silver is pyrargyrite, fibergite, acanthite, and then we have a good understanding of all of our alteration minerals. So yeah, we've been doing petrography, more from a petrographic perspective, but we do have a good handle on what the mineralogy is, but we haven't done any metallurgical tests yet.
You have shown the airborne data, but no IP. What kind of signals are there?
We do have IP that we did in 2020 at TV, Jeff, Spearhead, Vermillion, and C10, and we see good, strong conduct or chargeability anomalies associated with our mineralized zones, particularly at TV. I'd say those would be kind of moderate to high chargeability, corresponds with mineralization, and then there's very high chargeability that we're seeing with our graphitic mudstones. We also see the silicification in some spots corresponding to resistivity highs.
It's more resistive then?
Yeah, with the silicification it is. But again, it kind of depends, and I've been discussing this with our geophysicist, what the connectivity between the sulfide grains is. If they're completely encapsulated in silica, you'll have a more resistive rock. But in some of the cases, what we've seen with these rocks is they've developed enough of a fabric and the pyrite's been recrystallized. And in his experience, that increases the chargeability again.
Have you considered gravity?
No, we haven't done gravity. All right, right now we have a lot of geophysical targets, particularly from the SkyTem survey, which I think was very successful, and those SkyTem anomalies correspond very nicely with our IP anomalies. So now we're getting the boots on the ground and going out, not only drilling, continuing TV because this thing just keeps extending out, but we'll be following up on again, those two areas with the high bug anomalies at Vermillion and Scarlet Ridge. We'll be doing some detailed mapping, sampling, and drilling at those. You're welcome.
In terms of the drilling, can you give us some kind of a guidance how many meters you guys are planning to drill this year? So we understand the scale of the exploration.
35,000 is what we want to hit. We were aiming high last year, and we got cut 2 weeks before we really wanted to stop. So we would have hit close to our target of 30 last year, but we were unable to. But it's looking like we'll do a 4-drill program and ramp up to a 5th drill later in the season. But given the fact that we already have the pads built at TV and the archaeological clearance done in a lot of these areas, some of the early season bottlenecks we had last year, we don't have to worry about this year. So we're able to get started, on June 1st is what we're aiming for. And then it's just a matter of, is it going to snow 3 meters or not on October 1st? So we'll see. But we're planning to be extremely aggressive. Okay. Well, thanks again, and please come up and check out some of the drill core. Thank you.